Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 33 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the graph of f of x equals x squared. So let's just draw that real quick. That is what we call our parent function. It's the most vanilla, boring quadratic functions that we can think of. What we're going to do is we're going to transform it. So that's the parent function right there. Should be right there on the origin. Let's pretend it's sitting on the origin there. And it's transformed to create the graph g of x equals f of x minus 9. Okay, so g of x equals f of x minus 9. Well, we know that f of x equals x squared. So I'm just going to do a little substitution here. So I can say that g of x equals x squared minus 9. Okay, so what is this minus 9? That's the transformation. What does that do to this graph? Well, if we were to look at it like this, so g of x equals x squared plus c, right? That c is an add-in that we're going to add after the x squared. So this plus c regulates vertical movement. So if the c is greater than 0, which in this case it's not, it's minus 9, it's going to shift up. And if it's less than 0, which in this case it is, minus 9, it's going to shift down. So that's all it's doing. It's moving up or down based on whether the c, in this case it's minus 9, is greater or less than 0. It moves up. If it's greater than 0, it moves down. So it looks like we're going to move down here. We're going to kind of do like this thing right here. It's going to be the same graph here. So it looks like I made it a little bit narrower, but it's not supposed to be. It's just supposed to be shifted down there to about negative 9. So this is at the origin, 0, 0. And this is at 0, negative 9. So let's look at our answers. The graph of g is a reflection of the graph of f across the x-axis. Okay, so if we wanted to do this, right, we would need to do this. So g of x equals this negative f of x. So if you want just a pure reflection and it's not stretched or it's not narrowed at all, you just make it negative because it's going to be this a, g of x equals a f of x, and if you can make it less than 0, in this case it'd be a negative 1, you can actually flip it upside down. So it's not that one. B, the vertex of the graph g is 9 units to the right. Nope, not to the right. If we wanted to do that, it would look like this. G of x equals this f, and then we would do x minus 9. The minus 9 actually moves it to the right. Plus 9 would move it to the left. So that's how we would make that move to the right. C, the graph of g is a reflection of f across the y-axis. Well, that is not even anything we worry about here. It's already reflected on the y-axis. And then, so D, the y-intercept of the graph is 9 units below the y-intercept. Well, the y-intercept in both of these happen to be the vertex. So it's kind of a different way of saying it, but yeah, the vertex moves down 9 units. Double check. Let's look at our graphing calculator. So we're going to go to our y equals. Let's get our parent function in there, x squared. Graph it. There it is. Very vanilla. Now we're going to go back. We're going to add a new one. We're going to say it's this x squared minus 9. And that should shift it down. That red one is going to shift down, and we see it's going to shift down 9 to that negative 9. So that is the y-intercept, which happens to be the vertex here, is 9 units lower. So my answer is D.